Hi there. We're here today talking about the empirical rule. We know some of you guys can't be here today, so we're just letting you sit in on our class so you can hear me babble about normal distributions and the empirical rule, okay? All right, so one type of probability distribution is a normal distribution. A normal distribution is modeled by a bell-shaped curve. That's called a normal curve, and it's always symmetric about the mean. So notice the pictures that you see down here are pictures of the normal distribution. Notice it's bell-shaped. It's also, notice, only has one peak, and again, it is symmetric, and that middle is going to be your mean. Some things naturally fall towards a normal distribution, and so that's kind of why we are going to spend 11.3 talking about normal distributions. So a normal distribution with a mean, x bar, and standard deviation sigma has the following properties. First of all, the total area under this curve represents all the different values that are possible, which means it's going to be 1 or 100%. So what happens is that in the normal curve, things occur at different frequencies, and when they fall to a normal curve, they fall to this pattern. So if you add all those percentages up, that's going to be 1 or 100%. The empirical rule is basically where we're going to kind of estimate what percent of the data is covered, and we do that by looking to see what lies within 1, 2, and 3 standard deviations of the mean. So the rule, this is the empirical rule, essentially. That lets us kind of estimate the area under the curve, the percentage of area under the curve, when we don't have like a calculator or a standard normal table that we'll talk about tomorrow. So about 68% of the area lies within 1 standard deviation of the mean. So if we look at this picture, notice that if we have the mean, and if we go 1 standard deviation up and 1 standard deviation down from the mean, this area right here would be 68%. Okay? 95% of the area lies within 2 standard deviations of the mean. So that means if I went 2 to the right and then 2 to the left, and I covered everything, that whole piece would be 95%. Okay? Then, if we went 3 standard deviations away, that's going to be 99.7%. So again, if I went 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left, and I drew like the curve, basically all of this is going to be 99.7. Okay? That's kind of a lot, right? Just to be 3 standard deviations away. So there's a little bit that's left over here. This doesn't mean that this is 4 standard deviations away. It means it's 4 or 5 or 6 or 7. It's like however many away it could be, depending on the outlier, okay? These are the percentages of the empirical rule, but these percentages are actually going to be a little bit more helpful for you to memorize. And I know it looks like a lot right now, but by the time you do this homework, it's going to be a piece of cake for you. So can someone explain where you think, if you look at these 34 and 34, where do you think the 34 and 34 come from? Half of 68. Does that make sense? So the 1 standard deviation away, remember how that was 68%? Doesn't the mean cut it in half? So because the mean cuts it in half, that's where those 34s come from. Okay? Now, the next thing we said was that 95 was going to be within 2 standard deviations, right? Now that 95% though is all of this. What I shaded in yellow is what percent of that 95. So this whole thing would be 95%, but this part is what percent that I already shaded? 68%. So if I subtract 68 from 95, what I get is I get 27. So do you agree that then these two pieces here have to be split evenly with that 27? So if I divide 27 in half, what do I get? The 13.5. So that's where the 13.5 comes from. So the next piece was that we had this whole thing here. That was 99.7%. But in my green and yellow, which I know you can't tell the colors from my lovely screen, but in the green and yellow that I already shaded, what percent was already covered here? A total of 95%. So if I take the 95 off and I line up the decimal, that leaves me with 4.7%. What happens if you divide 4.7 in half? That's where the 2.35 comes in. Now, that being said, if we're looking at the whole blessed thing, all right, we said that this whole curve is what percent? 100%. And so we've already shaded 99.7% of it, which means I'm only left with 0.3%. And then what happens when we divide the 0.3% in half by the mean? The 0.15. So you can always, if you remember the, I think I have to stay here. If you remember the 6895 99.7 rule, you can always derive this. But to be honest, it's going to be easier if you just remember the percentages, okay? So you're just going to try to remember 34, 13.5, 2.35, and 0.15%. Okay? And again, what these do is, today we're only going to be dealing with things that are exactly 1, 2, or 3 standard deviations from the mean. So let's try that in example 1. It says, oh, and that's just what these are. These symbols sometimes freak people out. Do you guys see that this is just the mean? This is the mean plus 1 standard deviation, the mean plus 2 standard deviations, the mean plus 3 standard deviations, and then subtracting on the left. All right, so this says a normal distribution has a mean x bar and a standard deviation sigma. Find the probability for a randomly selected x value from the distribution, okay? So what I would like us to do here is I would like us to draw the normal curve, and we're going to practice. So you're going to try to make a little line, and you're going to make like a bell-shaped curve. Mine are not very pretty, okay? And then we're going to put one line in the center that represents the mean. And then after that one line that represents the mean, we're going to go 1, 2, 3 lines to the right, and then 1, 2, 3 lines to the left. Now we're going to put the percentages in. So we're going to put in 34, 13.5, 2.35, and 0.15. And then if those are the values on the right, that means that we'll just mirror those for the values on the left. So I encourage you guys to write these numbers down every time and on both sides so that they get in your head. Okay? So now let's look at what this question is asking for. This is, do you guys see that this is the x variable here? So it wants to know what is the probability of getting an x when we have this and it's between. Notice this right here is saying x bar minus 2 sigma. This is really saying 2 standard deviations, okay, 2 SD, 2 standard deviations below the mean. And what did we say that x bar itself meant? The mean itself. So this is telling us to go from 2 below the mean to the mean. So here's our mean. That's one of our boundaries. And now let's count to the left. 1, 2. And so those are my boundaries. These are what I want. I want everything from 2 below the mean to the mean. And I want to know the probability of getting something in that area. Don't we have the percents? So we're just going to add 13.5 plus 34. You don't have to write that, but just so you know where it came from. And so what percentage does that give us? 47.5%. That's the gist of it. That's all we do. That's it. Oh, you might think it's witchcraft.
It looks so hard.
Yeah, it looks so hard.
I know, guys. All right, so we'll, you guys, video people, we have to break for lunch, but we'll come back in a minute, okay? All right. All right, let's try example B together. Once again, just because we're getting used to it, I'll tell you how many curves to draw on the assignment. But let's just do another one, okay? Wow, that's really pretty. Okay, so once again, we are going to draw a little curve. We're going to have one line in the middle. And then how many on each side? 3, okay? So 1, 2, 3 to the left. 1, 2, 3 to the right. Except I did the right first. Okay, so then we can fill in the percentages. In a normal curve, then these will always be the same. That 34, 13.5, 2.35, and 0.15. So those will always be the same. So then after you make the normal curve, then we decide what we're talking about here. So here's x. What is this guy referring to? So this is the x bar minus sigma. So how many sigmas is that? Just 1. So this is going to be 1 standard deviation below. And then what does that one on the right mean? 2 standard deviations, which way? Above, to the right. Okay. So again, here was our mean in our middle. So we're going to go 1 below, back to the mean, and now 2 above, and we're really looking for this whole thing in here, which means that we would just add 34 plus 34 plus 13.5. Anyone have what that is? Excellent. 81.5%. That's all you really have to do. Okay? So I want you guys to try. You only have to draw 1 curve for this, okay? But practice drawing 1 more general curve and then see if you guys can answer A and B. Now when you get for B, notice that there aren't 2 boundaries. Do you guys see that? There's only 1 boundary. And what does this symbol here mean? Greater than. So you're going to have 1 boundary and then think about everything to the right of that. Okay? All right, we'll talk in a sec. Go. All right, so let's see what you guys have for the U-try. I drew my curve here, and I accidentally used the colors yellow and blue in my shading. Okay, but for this one, this was 3 standard deviations below to 1 standard deviation above. So I went from this boundary right here all the way to this boundary here. And then I added 2.35, 13.5, 34, and 34 to make 83.85. We okay with that one? All right. So then this one we said was 3 standard deviations below. So again, 1, 2, 3. Here's my boundary here. And this wanted everything greater than that. So it wanted everything to the right. So I shaded over that yellow and then over here also. So you could add up 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Or what would be faster? Yeah. Can't we take 100%? minus that 0.15. Isn't this the only thing that's not covered? And remember, we said that whole curve was 100%, and that's just a little faster way for us to get the 99.85%. Okay. Any questions on that? So those are when it's very generic. This is pretty meaningless, though, if it's just talking about a random mean and a random standard deviation. Let's actually do one where we have some numbers that we can discuss, all right? Example 2 says the typical amount of sleep per night for college students is normally distributed, so that means you can use the empirical rule, with a mean of 7 hours and a standard deviation of 1.7 hours. Well, before we even read A and B, let's draw a curve to represent this information, okay? So, once again, we'll draw this nice curve. I'm sure yours are nicer than mine, okay? And we'll make the mean in the middle, and we'll go 1, 2, 3 to the right, 1, 2, 3 to the left. And then practice putting in those percents. The 34, 13.5, 2.35, and 0.15. So in the normal curve, notice that like the taller, so these are even marks because these are saying it's this many standard deviations away. Do you see that the 34 has more area in it than the other pieces? That's due to the distribution of the normal curve. Okay, so we okay with that? Now, in the other problems, we didn't know what the mean was, right? In this problem, they tell us. What is the mean in this problem? 7. So that means that my mean, that middle value, I can now mark as 7. And it told us that the standard deviation was 1.7 hours. That means that each of these little marks that we have represents a difference of 1.7. So as we go to the right, we're going to add 1.7. So if we take 7 plus 1.7, that gives me 8.7. Add another 1.7, that gives me 10.4. Add another 1.7, that gives me 12.1. Now, I don't label the end, right? Because if we added another 1.7, what would that be? 13.8? And like maybe there are people that sleep longer than that. I'm a little jealous of their life, okay? But maybe there are. We leave the end open because it could be more hours of sleep that are not compensated for, okay? So now to go to the left, what will we do? Subtract. So we'll take 7 minus 1.7 to get 5.3. 5.3 minus 1.7, that gives me 3.6. 3.6 minus 1.7 gives me 1.9. And then again, we'll just leave the ends open. And I'm going to label this with hours. So that way this has a little more meaning. This is 3.6. So notice that when they give you the mean, the expectation is for you to write the values here. Okay? All right, so when given the mean and the standard deviation, write values under the curve too. Okay, so on the front, you don't have to label the bottom. You can just kind of eyeball it. But for these, I do want you to label the values under the curve in addition to the percents. But now that we have those, A and B become a piece of cake. So it says, what percent of college students sleep between 5.3 and 8.7 hours. Well, are those values that are on our label of the normal curve? They are. Here's 5.3. Here's 8.7. And it wants to know what percent is between those. So what would we say? 68%. Because we just added those together. Okay. This says, are we good with A? So letter B is about the same thing, isn't it? So we can just use the same graph. This says sleeping less than 3.6 hours a night is considered unhealthy. Oops. About what percent of college students sleep for a length of time that is considered unhealthy? Well, this 3.6 is the only number I see. Is that on the graph? It is. Okay. And this is about sleeping less than 3.6. So less than 3.6 hours is which direction? To the left. Less. Okay. So then we would just put those together. And what would that give us? Good. So 2.5%. That's it. Okay? So, the empirical rule is really nice when things are exactly 1, 2, and 3 standard deviations away from the mean. So practice, so if, for tonight's homework, if they're asking you about values that aren't on your graph, you probably added wrong, okay? So try this you-try problem. A survey of 20 colleges found the average credit card debt for seniors was $3,450. The debt was normally distributed, that means you can use the empirical rule, with a standard deviation of $1,125. So just make one graph, and then you can use that graph to answer both questions A and B. Okay, ready, go. Okay, so one thing is that when I'm labeling my graph, this is what it should look like. And so when I'm labeling these pieces, this is a boundary. So this 3450 isn't like in between one of the sections. That 3450 is like the mean, that line, okay? The 34 is the percent of values that would be between like this boundary of 3450 and this boundary of 4575. You guys okay with that? So these are the values that I got: 75, 1200, 2325, the 3450, 4575, 5700, and 6825. So the first one wanted to know seniors' credit card debt lower than 1200. 1200 was on our curve. Lower than 1200 would be everything over here. So we can see that that's going to be 2.5%. Agree with that? Okay. So then the last one, between 2325 and 6825, those were values that we got, 2325 and 6825. So we would want to add all of these together. And what happened when you guys added all those together? Not all at once. 83.85%. Okay. Okay. Any questions you guys have on that? Now, before I let you go, though, tonight you guys have homework. Here are the curves to draw. I don't, like, the curves are very similar, aren't they? But I don't want us just to draw one curve for tonight, and that's it. So, you can have one curve for numbers 3 through 10. I want to see another curve for numbers 11 to 16. Okay, so you can use the same one there. Then I need a separate one, though, for 17, 18, 31, and 32. The reason is because 17, 18, 31, and 32 all have different means and standard deviations. So you're going to have different numbers along the bottom. All right, So I don't need you to draw a curve for every problem in 3 through 10 or every problem in 11 to 16, but I need to see 6 curves when I check in the homework. Is that clear? Okay, great. Because they have different means and standard deviations. I feel like I just said that. Okay. All right, guys. Thank you.